I think this is an involved question. I think there's a lot here. And so we want to read this thing clearly and see what kind of motion diagram we could get out of here and what does it really mean here. Okay, so remember, we want to draw a motion diagram. Then we want to plot position, velocity, and acceleration. Okay, so here we go. So the first thing that I want to pay attention to here is that, let's read this. You are in an elevator that is rising at constant velocity. Okay, so what do I mean by that? Well, so we know that we're moving up at constant velocity, which of course tells us that the acceleration in this interval must be 0. So if I look at my picture, what would I have? I would have constant velocity vectors that go up. So in other words, if I'm looking at this here, I could say, okay, I know that in this situation, I'm having these constant velocity vectors. Let's say they're going like this here. And in this situation, we know that the acceleration is 0 here. Now let's look at the next part of the question. Suddenly you drop your keys. Okay, so what I'm going to do here is that I'm going to come over here and I'm going to start to label my points here so that it's a little bit more clear. So let's say it's already moving and here's where I'm going to start my clock. Is there an interval before this? Of course there is, but we're not going to get into that detail. So we got, here's my point 1, here's my point 2, and then I'm going to say this here. At point 2, the keys are dropped, right? The keys are dropped and they say that they fall dead onto the floor without bouncing. Okay, question, what does that mean? Well, if I look at my picture here, you could imagine that I have my elevator. Let's imagine here's my elevator. And what you're seeing here is that the keys, let's say, are at this point right here. And what we'll know here is that at this point, when it gets to, I'm going to call that velocity 2 right there. So if what we're seeing here is that we're seeing two different things here. Is that if you're moving at constant velocity, then the velocity of the keys must equal the velocity of the elevator. So there are two things that are happening here. But what we do know here is that there is a distance between the keys, right? So this is the distance between the keys and the floor of the elevator, right? It's two different, it's a distance, it's a displacement between the two. So what I'm thinking here is that when I go over here to the second point, what I'm going to do here is that I'm going to ignore the elevator for right now, and I'm going to say this is my point 2. At this point, this is where the keys are dropped. So I know beforehand I have a velocity that goes like this, and this is 1, This is 2. So at the moment that I drop the keys, what I know here is that the elevator and the keys are moving at the same speed. So when the keys are dropped, what this tells us here is that the velocity of the keys has to be the velocity of the elevator. So that means at this point, the speed of the keys is still the same as before. So if this is how big the speed is, this is how big the speed is afterwards at that point too. And then what happens? Well, it starts to decelerate.
Hey, Carlos,
Yes.
what tells you that the velocity of the keys is equal to the velocity of the elevator?
Let me ask you a slightly different question. You're in your car and you're driving 65 miles an hour on the highway. How fast are you moving?
65 miles an hour.
How fast is the car moving?
65. Yeah.
So if you're in the elevator, everything in the elevator is moving at the same speed.
Absolutely. Thank
So
you.
then what happens here is that what happens now? What happens now is that, as we already know, when we drop it in the air, there's going to be some deceleration. So what do I mean by some deceleration? Well, it's going to go up, it's going to go up, and at some point, what's it going to do? It's going to stop. So what I'm assuming here is that at the very top, you know what? I got to move this down a little bit. I need that space. Okay. So once it gets to the top, well, there's really a lot that's going on here. I'm assuming that the elevator has not caught the keys in the air. And I'm going to assume here that the keys then are now going to change direction and fall back down. And so as they fall back down, remember, this is still v equals to 0. And then what happens to the keys? Well, they start to speed up again. But I'm gonna assume here that at some point, let's say right here, this is now the location where the keys in the elevator collide. So this is the location where keys and elevator collide. And so at this point, we're going to say that the keys instantly stop. In other words, when I say instantly, I really mean that the acceleration at this point is, the deceleration is infinite. Now, can I really say that? Of course not. But that avoids the issue of us having to grow, worry about another dot. But at this point, then there's the acceleration of the elevator that just stops that dead.
Hey Carlos.
Uh-huh.
So if you were to continue this with an extra dot, though, wouldn't it be going the same direction as it was initially at the same velocity? Because the elevator's carrying it, it's just on the floor now.
No, we will get there. We
Okay.
will get there. But I thought that the keys was the hardest piece to really get a handle on that. The elevator is going to be moving at constant velocity no matter what. And I think graphically, it should be quite easy to actually show that. So let me try to draw this as a graph now.
Carlos, I had a quick question.
Sure.
So right when the velocity is getting slower, is that like the instant in which the keys are dropped, really?
No, I would say that here's at point 2 is where the keys are dropped.
Okay.
So as it's getting smaller, as the arrows are getting smaller, what I'm really seeing here is that I'm seeing that at that there's a deceleration of the key due to the acceleration due to gravity. So gravity is slowing it down, but I'm making the assumption that it never really, that the elevator does not take its place until it doesn't collide with the keys until after the keys have started falling down. I don't know if that answers your question, Tessa.
Yeah, I think I was curious about whether we were able to assume that the speed of the initial dropping of the keys was like faster or slower than the speed of the elevator.
What do you mean? What do you mean the speed of the initial dropping of the keys?
So I'm picturing like if you're in the elevator and you drop your keys and the elevator is continuing the velocity of moving up, at what point would the keys falling have like a greater speed than the elevator moving
See,
upwards?
but it can't. And the reason why it can't is because the keys in the elevator are moving at the same speed. Because if you're stationary on an elevator and the elevator's moving up, everything within the elevator must be moving at the same speed. The only way the keys could be moving faster is if you take the keys and you throw it up with some initial speed. But in this question, it says that you drop the keys. So let's go try to plot this motion. Okay, so if I go and I try to plot this motion, what I'm seeing here, so the question is, so they're moving at the same speed but different directions? No, they're moving in the same direction. Look at the picture over here. The picture that you want to pay attention to is right here. The elevator's moving up, the keys are moving up, they have the same, until you drop them, they have the same speed and the same direction. Let's plot this to see if we could get a handle on this.
So where V is equal to 0 at the top is where the elevator stopped, and then it started.
No. The elevator does not stop. It just keeps moving up. Let's draw the graph, and I'll see if I can answer those questions that are being asked. So what I'm going to do here is that I'm going to come over here. Okay. And then I'm probably going to do this type of thing. And then I'm going to move up here a little bit. Like this. So here we go. So what do I know about the elevator? Well, for starters here, I'm calling this Y, V, and A. What do I expect here? The elevator is always moving at constant velocity. So if I look at this thing, that means that the elevator, if it's moving at constant velocity, it must always be doing this type of thing here. Right? So this guy is the elevator, which this guy is at constant speed, no matter what. So if I look at this guy here, what does this tell us about the elevator? Well, the elevator, well, if it's moving at a constant speed, then I'm going to just say, this is the speed. And if I look at the acceleration, if I try to draw a nice, smooth line for the acceleration, then I'm saying that this guy should have 0 acceleration. Okay, right? So this guy should have 0 acceleration for the elevator. This guy should be V elevator, which is a constant, and that's what that slope means. Now note that this location here represents what? This really represents the floor of the elevator, but the keys are not on the floor, they're above the ground. And that's what I called over here. When you're looking at this guy here, you could see that I says it's delta y. So in other words, this guy is right here. Man, I hope I don't run out of space. Now note, so what I'm seeing here is that I should label these things. Let's call this interval number 1, right? This is interval number 1. And to make it a little bit easier to see here, I'm going to say that this guy's all interval number 2. And then at some point, there's an interval number, I'm going to call this interval number 3, even though it's not a different interval, it's the same, but it's just to make it a little bit more clear how we actually see this thing here. And then there's really an interval number 4 where the keys and the elevator are both moving up at the same time. Okay, so let's do this here. So let me set up an interval here. So the first thing is that when do I drop the keys? So I'm going to come in here. And how do I want to do this? I'm going to say that this line here represents when I drop the keys. So in other words, this is my interval number 1. Now, when I look at this thing here, what I have to do is that they have to have, you know what? I'm going to move my red dot a little bit further down. They have to have the same speed. So if I look at this guy, note that the keys and the elevator have parallel lines, assuming that I drew those parallel. So now what happens? The elevator continue and the keys continue to go up, and I'm going to call that interval number 2 until it stops. So let me try to draw a curve. So I'm going to say that my interval number 2 here is going to be this interval right here. So here's my interval number 2. So now what happens here is that the keys go up, and what do? They got to stop. So if I look at my curve then has to do what? A changing slope until what? Right at this point, my slope must be equal to 0. So what I'm seeing here is that I'm looking at the speed of my elevator, of the keys. Look at the first part. The speed of the keys and the elevator should be what? The same. So I'm just drawing it a little bit, and clearly the red is that. And look what happens to the speed. The speed is it's going to go what? It's going to go to 0 right there. So what that means here is that during this spot here, you're seeing the speed decrease linearly till it stops. And the only reason why it's doing that is because initially the keys are moving with 0 acceleration, and then they start to decelerate and they move at this constant acceleration right here. So then what happens here? The keys start to fall, right? Now I'm on interval number 3. So the keys start to fall, and I'm going to say that if I do this properly, if I keep those 2 square intervals that I'm talking about, I'm going to call this interval number 3. So what happens? This thing now starts to speed up, but if it starts to speed up, that means that my curve should be getting steeper. And then here, at this point here, is where the keys collide with the elevator. And so what happens after this? Then the keys continue to move with the elevator up like that. And that would be what I would call my 4th interval that I mentioned, but I didn't do that. So what actually happens to the rest of the curve? Well, the acceleration is constant because we can only deal with constant acceleration intervals. And except till right here. And then right in here is where we get we have 0 acceleration. And so then this guy shoots up. Oh man, what happened? It shoots up and then it moves with 0 acceleration. But the velocity, when you look at the velocity here, what ends up happening here is it continues to do this. So if I draw this properly, it should be at a constant velocity here. And then there's a discontinuity, because all of a sudden there's an infinite acceleration of the keys so that it now moves at the same speed as the elevator. And that's the motion of the keys, where this guy, of course, is a constant acceleration that's negative. So there's a lot involved in this problem, a lot involved. Now, is there really a discontinuity? Not really. They're typically continuous here. Okay.
What does it mean on the velocity graph when the velocity is going vertically up? What is that? How is that translated?
Okay, the way it translates is that, let's go back here. And what we really got to look at is we got to look at this region right in here. So let's look at that region. So what really happens here is that I now have the keys. The keys are about to collide with elevator. So what I'm seeing here is that they're on the way down, right? They're on the way down. And then this is the floor of the elevator right here. Okay, that's the floor of the elevator. So when I look at this thing right here, what you're seeing here is that the maximum speed going down is right at this point right here. But the very next point, so it stops at the very next point here. Now note, I staggered it because, you know, it's really, maybe I should draw this a little bit different. I think I know how to do it now. So this is the speed. Now I'm going to exaggerate this. This is the speed. And note that there's a little tiny gap right there. Right? There's a gap. And that gap, let's say, is about the size of an atom. So it's a tiny, tiny gap. The very next dot is that it comes to a stop. So you're going from the fastest to the smallest. So what this means here is that what's changing the speed of the keys? The acceleration due to the elevator. It just stops it instantly. And so that discontinuity, the way I drew it here, is really not correct. What you're really seeing here is that if I'm looking at, let's say that this is my slope right here. So if I was to draw that curve, what you would see here is that you would see this. So you would see the keys coming down. And then what would happen here is that there's that little gap. And that little gap essentially says that there's a little bit of spacing so that it actually kind of goes up like this at an angle. But you can't really tell because it's so tiny. And then this thing is then just moving at a constant speed then. So it's just a really, really tiny thing. So that this is a non-zero time interval.
Hey, Carlos,
Yeah.
when on the velocity graph, when it intersects the I guess you would say the time axis, it would be at
0. That's where it stops.
it would be at 0. That's where it stops, and that's when it's colliding with the elevator as well.
No. Here is where it collides with the elevator. Because look at the graph here. See how right up here, the slope is 0? The red is the keys. So this is the line right here. See, here's where the keys collide with the elevator. That line between 3 and 4. Here is that this is where it reaches the top of the trajectory. And what I'm talking about is I'm talking about right here. Right here. Here's where it's at the top. That's where this is 0 because it has stopped and now it's on its way down.
Oh, okay, that makes sense. Okay, thank you.
Okay.
And then Carlos, for the graph that you just drew, where you say the acceleration of the elevator, wouldn't it? Or I thought that since the elevator was moving at constant velocity, its acceleration was 0.
No, that's not what I was really saying here.
Okay.
When I said here is that what stops the keys from moving down? It's the elevator's floor, not the actual acceleration of the elevator, but it's the floor that really causes the change in velocity in the keys.